Так, это салептопи.
საღამო მშვიდობის 5 წუთში დავიწყებთ. Good evening. We will start in 5 minutes. საღამო მშვიდობის მოგესალმებით ყველას. ზუსტად 25 წლის წინ ჩვენ ყველანი დიდი ნაწილი აქ ყოფების დმანიში ვიყავით, ვამთავრებდით იმ სეზონს და მაშინ ალბათ ვერ წარმოვიდგენდით, რომ 25 წლის შემდეგ შესაძლებელი იქნებოდა საქართველოში აი ამ ტიპის ღონისძიების ჩატარება. ეს იმას ნიშნავს, რომ ყველაფერი შესაძლებელია, უნდა ყოველთვის მიზანი კონდეს და მერე შეიძლება ეს ყველაფერი შეასრულო. მე მინდა ყველას ძალიან დიდი მადლობა უძღვნა მობრძანებისთვის. მინდა გითხრათ, რომ ეს ჩვენი დღევანდელი ღონისძიება არის ერთის მხრივ საერთაშორისო სამეცნიერო კონფერენციის პრელუდია და მეორე და ალბათ ყველაზე მთავარი ის გახლავთ, ეს არის მეცნიერების ფესტივალის ფარგლებში. და ეს მეცნიერების ფესტივალის იდეის ერთ-ერთი თანაავტორი ჩვენი დაწესებულებაც იყო და მე მინდა ძალიან დიდი მადლობა უთხრა ყოველგვარი დიპლომატიის გარეშე განათლების და მეცნიერების სამინისტროს. ბატონი გია შერვაშიძე იყო მაშინ ერთ-ერთი პირველი მხარდამჭერი და ქალბატონი ირინა დარჩიას მინდა დიდი მადლობა და ყველა მისი გუნდის წარმომადგენელს, რომ შესაძლებლობა გახდა, რომ ეს მეცნიერების ფესტივალი გაჩნდა. და პლუს ის, რომ მის ლოგოზე ზეზვადამზია წარმოდგენილი, ესეც ალბათ განსაკუთრებულ სიამოვნებას გვანიჭებს. მეცნიერების ფესტივალი ნიშნავს მეცნიერების სიხარულს. გარკვეულწილად ფესტივალი ყოველთვის სიხარულთან და კარგ განწყობასთან ასოცირდება. ასევე არის დღევანდელი საღამოც. ჩვენ გვაქვს საშუალება, რომ დღეს მოусმინოთ. მე არ დავამეტებ ალბათ ჩვენი სფეროს ერთ-ერთ ყველაზე ცნობილ წარმომადგენელს. ის თვითონ მოგიყვება თავის ისტორიის შესახებ. ერთი შემიძლია გითხრათ, რომ დონ ჯოჰანსონი გარდა იმისა, რომ არის ძალიან მაღალი რანგის მეცნიერი და იღბლიანი მეცნიერი, ესეც მნიშვნელოვანია, რა თქმა უნდა. ამის გარდა მან შექმნა ეპოქა სწორედ მეცნიერების საზოგადოებისთვის წარდგენის. და უნდა გითხრათ, რომ ჩემი თაობის ბევრი მეცნიერი ინსპირირებული გახდა სწორედ მისი წიგნით. ეს იყო ერთ-ერთი ბესტსელერი ლუსი, რომელიც გამოვიდა 91 წელს და მათ შორის მეც უნდა გითხრათ, რომ ჩემი პროფესიული გადაწყვეტილება იყო დაკავშირებული ამ წიგნის წაკითხვასთან და უნდა გითხრათ, რომ ალბათ მაშინ ოცნებაშიც ვერ გავივლევდი, რომ ამ წიგნის ბევრი პერსონაჟი დღეს ან ჩვენთან თანამშრომლობს, ზოგი დღეს აქ გახლავთ და კიდე ერთხელ გავიმეორებ იმას, რომ თუ მიზანს დაისახა, ყოველთვის არის შესაძლებელი მისი მიღწევა. ასე რომ დღევანდელი დღე პირველ რიგში მომავალს ეძღვნება. ბევრ ახალგაზრდას ვხედავ და მათ მინდა უთხრა, რომ ეს ის მაგალითებია, რომელიც არის დაკავშირებული ცნობის მოყვარეობასთან, პატერაკთან, ინტერესებთან და მეცნიერებასთან კავშირი ეს ნიშნავს იმას, რომ ეს არის მომავალთან კავშირი. ასე რომ ძალიან დიდი მადლობა ყველას მობრძანებისთვის. ეხლა დღევანდელი ლექცია იქნება ინგლისურად და მე რამდენიმე სიტყვით წარმოვადგენ კიდევ ერთხელ ჩვენ სტუმარს. It's a great honor for me today to welcome Don Johanson. I would stress that a few years ago when we decided to have science festival, I couldn't imagine that our profession was presented so strongly. If you saw the science festival logo, there are Dmanisi hominids on it, making selfie, right? And this is a continuity of the one hand National Museum strategy promoting science. And I'm very happy to say that first science cafe in Georgia has been created here, and first speaker was Michel Brunet. So now we are continuing it, and we are giving floor to real, without any doubt, one of maybe most famous paleoanthropologist who created, may I say, a case which inspired many scientists to be in this field. You know, we have here a fantastic group of the scientists, and I'm really very, very happy that I got chance to welcome you. If I will introduce all of you, it's like to have a superstars, right? And my friend, the Minister of Culture, is very much interested in jazz. He couldn't come today, and he asked me, I told him, we will have group people like to have Herbie Hancock, and same time Ray Charles will come back, You are like these stars we have here with all over the world from different countries, and we will have tomorrow a chance to learn more. It's not many times you have an opportunity. One had a scientist working in East Africa and going to the Siberia, and all we are here together to study our history. So and we are giving floor to Don Johanson, somebody who, beside of course, great scientist, I think everybody will agree, since discovery of Lucy and promoting Lucy in public, we got a new paradigm in our field. We had different important stages, starting with early 20th century, then was leaky time, and then started from dawn. After this, it shows that there are new discoveries, and we had then fantastic discoveries which we got with Tim's group, and here is Behane, and Michel changed, pulverized the world, and Rick here. So the discoveries in Siberia, some discoveries in Georgia. So we had a lot. But I wanted to say everybody that the Lucy became iconic. And I'm very happy to present you Don Johanson, somebody who inspired me to go in this field. I don't know how good it was for field, but I'm sure that this book was something which changed maybe view how we can see science. And today, even I mentioned the science festival, it's about presenting what should be science, how we could be closer to science. And presenting you, it's an opportunity present of one of the very key success which was in our field, and I'm sure some of them you will be inspired to work in our field, at least friend of our field and friend of science. So it's my pleasure to invite Don Johanson. It will take a long time to tell all his bio. Just simply I would say that Don Johanson is one of the famous paleoanthropologists, our history, and he was an author, one of the biggest discovery in paleoanthropology. Please.
Thank you, David. Good evening, everyone, and I'd like to welcome all of you here tonight, and to express my appreciation, particularly to David, for reading that pirated Russian translation of my book on a train that inspired him to also join the search for understanding where we've come from and how we became who we are today. And it's to David and Friedemann Schrenk's organizational skills and their team that we've all been brought here to this wonderful country, to this fascinating city, filled with some of the friendliest people I've ever met. I don't know why I didn't get here sooner, but to congratulate all of them for the work that they've done to encourage us to be here. And over the next few days, we will be addressing and talking about one of the more complicated parts on the human family tree. It sounds simple when you say 100 plus 25 years of Homo erectus, but every person who has come here as a scientist has, I think, his or her own idea of what is Homo erectus, what is not Homo erectus, and how it fits in. So I'm looking forward immensely, since this is not an area of specialty for me, and I've come here to learn from the people who are the experts. Also like to, as I said, especially welcome my colleagues. It's a little intimidating, when a lot of them have heard me speak before, a lot of them have read my books, a lot of them have read articles that I've published, and I appreciate your staying on to listen to this. And I appreciate the fact that so many of local people have come out to learn something about themselves and something about their ancestors. I have had a remarkable opportunity and privilege beginning in 1970 of working in Africa, and particularly in Ethiopia, which has become a real focal point for understanding the last 6 million years of human evolution. We don't get as far back as Michel Brunet, who is sitting up here, who gets back to close to 7 million years. But I'll speak about that a little bit more detail later. It has been a very rewarding time for me because when I left the University of Chicago in 1970, 1972 or 1973, to work in northeastern Ethiopia, I had, sounds like a giant Zika mosquito or something. But I had no idea that I would have the opportunity to work there for so many years and to participate in a number of discoveries that have allowed us to shed new light on some of the early stages of human origins. And David particularly asked me to entitle this talk the Lucy story. It's a story, of course, that she has been a very major player in this story. Her species, Australopithecus afarensis, we'll get used to that as we go through this. And it has been very much an intimate story to me because I have been part of that from the moment of discovery to today. And as I am now working on my autobiography, it's amazing to look back from this perspective to the beginnings of my career as opposed to when I was a beginner looking forward. I had no idea where I was going. Lucy, of course, has become a household name. I think that people recognize her as a human ancestor. She did get her name from Lucy in the Sky with Diamonds, a Beatles song. And she is an important benchmark, not only for we scientists, but also for the average person who is interested in human origins. We're all interested. It's the first question we ask ourselves when we are children. Where did I come from? Because she is identified with our ancestry and is an easy name to remember. And she does bring with her, more than 3.2 million years ago, she does bring with her an important perspective on who we are and how we fit into the natural world, which I will talk about towards the end of the presentation. Now, I think I can say that we have a pretty good idea of what happened the last 5 or 6 million years, at least the broad strokes of what the human career looks like. We know that our most ancient ancestors, things like Tumai, things like Ardipithecus, and so on, were rather ape-like and had very small brains. They had large ape-like faces. And through time, because of the changes brought about by natural selection, there was selection for a reduction of face and an increase in brain size. This is often referred to just here as Homo erectus. And then ultimately, the evolution of our own species, which Linnaeus called Homo sapiens, which means wise man or intelligent man. But I read the same newspapers you do, and I wonder if that's the appropriate name for us. What is part of the theme that I will talk about several times this evening is that the earliest appearance of mammals that would be comfortably placed on the human family tree, walking on 2 legs, as we all do, a very unique and strange way to get around. When you look at the world of animals, they're all essentially 4-legged animals. But this group goes back into its oldest dates in Africa, and perhaps as much as 7 million years in the Chad specimen, for example. And then we see the emergence of a number of different species. We see the appearance of our own genus, which means Homo, which of course is Latin for man, in Africa at least 2.8 million years ago. So it must be even older than that. And then ultimately, about 200,000 years ago, we see people of a modern anatomy and the beginnings of modern or advanced behaviors. Charles Darwin, who of course is well known to many of you, in his book on the origin of species by means of natural selection published in 1859, he suggested on the very last page that this idea he had, descent with modification, or simply put, evolution, also would bear on the origins of humans. In 1859, this was not a very popular idea, as you can imagine. It's okay if the animals evolved, but not if humans evolved. We were sort of divinely created. And the only thing he wrote in his book was, light will be thrown on the origin of man and his history. That was enough to make many people angry about putting us equal with the animals. But in 1871, after, I think, drinking many cups of tea with his close friend Thomas Henry Huxley, and really thinking about the origins of humankind, he wrote in a book which was called The Descent of Man, that Africa was likely the place where humans first began, because he and Huxley and others went to the zoo and saw our closest living relative, chimpanzees. And they surmised that there must have been a common ancestor to the modern day African apes, as well as to modern humans. And of course, we now have extensive field studies, people who have been in the field living and studying chimpanzees in the wild. Of course, what comes to mind is Jane Goodall, who has the longest continuous field study of primates anywhere in the world. And she began to write about chimpanzee behavior, in addition to the fact that they were not only looked like us, they acted like us. You probably know some people maybe who have a little bit too much to drink on Friday night who act like chimpanzees. And Jane has just recently posted on Facebook that a certain presidential candidate in the United States is acting very much like a chimpanzee. I think you can figure out which one that is. And ultimately, we have the genetics. We have the human genome, we have genomes of many other animals, and we see how closely we are related in our DNA with chimpanzees. So there's no longer any question that these two creatures are closely related to one another and that they had a common ancestor in the past. So with that in mind, Darwin and Huxley both suggested that the earliest true humans would be found in Africa. This was at a time when the field of evolution and the thinking focused on Europe, because there were white European males who were doing that work. So where is it better to become human than in Europe? And after all, nothing happens in Africa, right? So people focused on Europe. Neanderthals were found 3 years before Darwin's 1859 Origin of Species. Cro-Magnon was found later in the 1800s. Many Neanderthals began to be found around the 1900s. And it seemed to solidify, to support the idea that Europe was the place where humanity became human. But it took until 1924, when a small infant skull was found in southern Africa. And if you look at this satellite picture, that's as far away from Europe as you can get, latitudinally. And this was the famous Tong child found by Raymond Dart, and people began to focus on Africa. It wasn't until another 12 years after that that adult Australopithecus, like the Tong baby, were found at places like Sterkfontein in the Transvaal. But there has been a tremendous amount of attention focused on Eastern Africa, particularly beginning in 1959, essentially on July 17th, 1959, when the late Mary Leakey found a beautiful skull or cranium at Olduvai Gorge in Tanzania, and the focus began to shift very dramatically from southern Africa to the Great Rift Valley in East Africa. So here you have what we call the Horn of Africa, because it looks like a horn. You have the Afar region, which is the northeastern part of the Rift Valley. This is all Rift Valley. It's large there because the continents are moving apart, and that's the largest part. You see how it narrows down here. And if you travel down here, you get to Lake Turkana in northern Kenya, where Richard Leakey and his team and other teams have been working. This is a wonderful place to be, the Rift Valley. Africa's Rift Valley is tearing apart the crust of the earth and exposing for us very ancient layers of rock that contain fossil remains of all kinds of animals, from tiny little mice up to huge elephants, and fortunately remains of our ancestors, and very often remains of the stone tools and so on that they made a long time ago. So the Great Rift Valley has been a place of focus for paleoanthropology, the study of human origins, really since the late 1950s, and there are numerous teams today working in various parts of that Rift Valley, adding to our understanding of human origins. The site we're going to visit tonight is the site of Hadar, just here. This is the capital city, Addis Ababa. And as you travel into the Rift Valley, there's a river you can barely make out, and we're situated right on the banks of that river, which I will show you shortly. And there are numerous sites in that Afar region. This is essentially the first place I saw, the first vision I saw in 1972 of the site known as Hadar. And that's a local place name that the local Afar people have given it. And it was like a dream. Very different from the places where David is working, in Dimanisi, where you're excavating in place. You can see that the geological deposits continue way off into the distance. They are very clearly layered. So this was probably like in large part, a large lake. So deposits were very quietly laid down. There are layers of white rock, which you can see over here. Those are volcanic layers of volcanic ash that allow us to date the site. And when we first drove down into that site in April of 1972, we were surrounded by bones all over the ground. It was a very fossil-rich area. The hope was that we would find human ancestor fossils at this site. So this gives you a wonderful perspective on where it is we work. And here is an aerial picture I took a few years ago when we were doing some filming. Now we could have a wonderful drone. We didn't have them in those days. And I show this because you can see how these deposits continue northwards. We're looking north just here. This is the Awash River that provides us with a permanent source of water for our expeditions, sometimes up to 30 or 35 people in the field at any time. And I don't know how many of you have spotted my field camp in this picture. It's right there. That little white dot is where we go and live in tents like this for 2 to 3 months a year, under very hot conditions, sometimes up to 35 or 40 degrees centigrade, so it's very hot. All we have are small sleeping tents. You see the camp itself. Here's a tent for working. This is a tent for eating breakfast, lunch, and dinner. This is the kitchen tent. Over here we have a staff of people cooking for us. And we have scholars, students, colleagues from all around the world who come and work together as an integrated team. Geologists, paleontologists, people who study fossil pollen, people who study archaeology, and so on, to try to piece together this fascinating story of where we came from and how we as a species, or we as hominins, have survived over the millennia. And you see how conveniently we are situated next to the river itself. This is a typical field season team. This is in the early 90s. We first began working in this area in the 1970s until the Ethiopian government put a moratorium on research in the early 80s. And then we have resumed work there beginning in the 90s and are still going back from time to time. And you see a lot of local people, the Afar people, take great interest in working with us. They provide us with security. They provide us with an detailed, in-depth knowledge of the landscape. And they feel very proud that Lucy was found there where they live. These are Muslim people. They are very devout Muslims, but they have taught me a very interesting lesson about the fact that there's very little room in the Quran for the evolution of humans, just like in many other religions there isn't. And how do they incorporate this into their lives? I heard them praying one night, the last prayers of the day, and they were thanking Allah. I could hear the name Allah, and I could hear my name, and I could hear Lucy's name, or as they call her, Halomali, which means you are wonderful or you are beautiful. And I asked someone what they were saying. And this translator said, they are thanking Allah for bringing you here to find the first human, which means that their tribe was the first tribe on the planet and gave rise to everyone. Now that's an interesting lesson, isn't it? So you have an integrated team like this that one has to support out here in the middle of really nowhere, and the search begins. Now, how do you find these fossils? We were talking about the drone earlier tonight. The only way you really find them is to walk the ground, like these people are doing in the background. They are participating in survey, looking for fossils that came out of the ground in the last rainstorms that eroded those sediments. And you can see in the foreground, here's a nearly complete elephant foot that is eroding out of the ground. That elephant walked that landscape, died there, fell into the lake, and became fossilized, in this case, about 3.3 million years ago. Teams like this, there's only, I think, 6 people in this group. This is a very specialized group of people who focus almost exclusively on looking for human remains, hominin remains, fossils of teeth and jaws and skulls and all sorts of bones that they would recognize coming from a human ancestor. And perhaps this group would spend 2 or 3 days in this area, looking and looking and looking. Sometimes if you walk this way, you miss the bone. It's only when you come back this way, when the light is just right, that you see it and recognize it. And then we begin to collect specimens. So here's an example of one locality. 417 is a specialized number in our catalog. And it all started with the discovery of this one little upper molar. This is a tooth, a molar from the upper jaw. And you see the team has gone into action. There's a geologist here. There is a paleontologist or paleoanthropologist, that's Bill Kimball, who is now the director of the Institute of Human Origins, where I also work. And it was down here where this tooth was found. And we are beginning to start at the bottom and work our way up with bucketfuls of dirt that are screened through these screens to see what else was there. And ultimately, we got the entire portion of the lower face, a very important discovery as it was. But it began because someone with a very good eye recognized that tooth. This is the exact place where in 1974 I had the opportunity to see this one arm bone that led to the Lucy skeleton. And you see a number of people here. It was just about here where people are filling bucketfuls of sediment, of soil and sand and clay and so on, and screening that over here. And then we took that and put it into burlap bags, and we brought that to the river, and we washed it in very fine mesh screening so we wouldn't miss even the tiniest sliver of tooth. And it was a wonderful Sunday morning when I was out with my graduate student, at that time, Tom Gray. You can tell he's a graduate student, he's doing all the work. And there I am in the background, and it was on this slope just here. I was walking back to our car. Our Land Rover was over that hill, and I happened to look over my right shoulder, and I saw a piece of gray bone, about very small. You'll see a picture. And I recognized it. There it is. I recognized that as the bone that is in your elbow that allows you to flex and to extend. So it's this bone right there. And because we have spent, all of us who are paleoanthropologists, lots of hours in the laboratory learning to identify bones, I knew it could not be from a monkey or from an antelope or any other kind of animal. And as I kneeled down to look at it, I looked up this slope and I saw a piece of skull and a piece of jaw, and we realized at that moment that there was part of a skeleton. And it's fascinating how it isn't really luck. It's everything comes together at the right moment. You are in the right frame of mind. You are carrying the right search image in your mind. You are paying close attention. You are never, your eyes never leave the ground. And it's interesting because when I first saw the bone, I saw footprints within a meter of the skeleton. And those footprints were left the year before by a geologist. Why didn't he see this skeleton? Because he was looking for rocks. I was looking for bones. And if I had not found that bone that morning, we would probably never have come back to this location. And Lucy would have been swept away in the next major rainstorm. So again, very carefully working our way through all of the sediments, making sure that we would collect as much of this precious specimen that had sort of been sealed for 3.2 million years in suspended animation, dying along the edge of this lake and coming to rest in these sediments. Think of everything that's happened over the last 3.2 million years. Yet she was there, and fortunately I was there 3.2 million years after to find her. I show this picture because it's the first time that we began to assemble the pieces of Lucy. We would get a piece of rib, and a piece of skull, and a piece of jaw, and a piece of arm, and a piece of thigh bone or femur. And then, most astonishing of all, we got half of her pelvis. And having the pelvis was very important because of what it told us about how Lucy got around. It was a pelvis of an individual like the pelvis you are all sitting on. We walk on two legs. And I also show this picture because this is a very wonderful man, Boris Tayeb, who is a geologist. Lives in Marseille now. He, at that time in the late 60s and early 70s, was one of the pioneers of studying the geology of this Afar region. There were many geologists working there, that they were working on things like the volcanoes and tectonics, but Maurice was a classic sedimentologist. He was studying the layers, what that told him about the past, and he was mapping them. And he recognized when he was walking and studying the geology that there were bones everywhere. You know, it's not difficult to miss an elephant skull, right? And I was working in southern Ethiopia at the time with a American-French team in the Omo region, and I stopped in Paris very often on my way back to the United States. And at a party, I met Maurice, and he was so excited. And he told me, he says, you know, you think you have the bones down in the Omo. You come with me to the Afar. And I went to his laboratory, and he showed me pictures that he had taken of teeth of pigs and elephants. And I could tell that these pig teeth, yeah, we study pig teeth too, you know, came from a time period that was older than 3 million years. I knew that from my studies in southern Ethiopia. And in 1972, or 71, when Maurice and I met, any human ancestor older than 3 million, you could fit into your hand. There was a piece of jaw, there was a piece of arm, there was a tooth, and that was all we knew. There were no fossils. And as a young scholar still working on my thesis for my doctorate, I was running around the world measuring chimpanzee teeth, if you can imagine. Not very exciting. But I thought if we could find human fossils older than 3 million, we would be able to open up a very new window on a much deeper past for human evolution. And Maurice was one of these really bubbly, excitable people. And he just wanted to get me there. And he invited me and a French colleague and another American colleague, and we went there. There were no roads. There were no maps. It was terra incognita. And we drove for days, 6 weeks, slept on the ground, made sure there weren't any scorpions and snakes. And we decided that Hadar was the best place. And that was really exclusively due to Maurice's vision. And he didn't know at that time that he would be opening up the last remaining large, extensive area of the Rift Valley to discoveries that are being made perhaps at this very moment. So this is the familiar picture that has become, I like the word that David used, that's become iconic. We think of Lucy not so much as just bones. We really think of her as a person, as someone who lived, someone who walked on this planet, someone who lived with other members of her species. The questions of, you know, did she have babies? How many people lived with her? How did she make a living? Predominantly as a vegetarian, I would say. And of course, people now are asking questions about how did she die, which I will return to in a minute. And what was unique about it is that there were upper limbs and lower limbs associated. There was most of a pelvis here and the thigh bone. So we had the pelvis, the knee, and the ankle, all associated with the same individual. These weren't a fragment from here and a piece of jaw from there, and this is one individual. There's no duplication of parts. So this is one individual, about 1 meter tall, 1.1 meters tall, very short. A full adult, we know that she was an adult because she has her third molars, We call them wisdom teeth. I don't know what you call them here. But she was an adult, and it turns out she was one of the smallest members of her species. We know this now because we have hundreds and hundreds and hundreds of specimens of her species. Not as complete as this, but we have lots of specimens. So we were able to say something about body proportions. We were able to say something about the size of her brain. Unfortunately, most of her face was gone, but there was enough of the top and the side and the back of the skull. She had a brain about 125% of the size of your brains in this audience. She had a brain that was very small, much like a chimpanzee of today, under 400 cubic centimeters. And we were able to look at this as an individual. And I think this is one of the aspects of Lucy that has made her so memorable, that she has a personal name. It looks like a human skeleton. And she is very much the reference point for most people who are not experts in paleoanthropology. When they read in the newspaper that a new specimen has been found by someone in Ethiopia or Kenya or South Africa, as we've heard so much about this last year, they will say, older than Lucy, or younger than Lucy, or more complete than Lucy, or less complete than Lucy, a different species from Lucy. She is the benchmark by which other people compare these new discoveries. And because we have now over 400 published specimens of her species, Australopithecus afarensis, and you can tell that afar is in that word, in the species. Remember, we are sapiens. She is quite a different classification. And that was chosen to honor the region and the people, the Afar people. And that's why she was given the name afarensis. The geology was very good to us. We had volcanic layers of ash. It took a long time to really figure out the details of how old that was. But that date of 3.2 million years means 3,200,000 years ago. It's actually 3,180,000 years ago, plus or minus 20,000 years. So we have a very accurate date. We know when she lived. And she captured the attention of people. And she became, as we heard from David, this iconic reference point. And very quickly, but because so many specimens of her species have been found, her species, which lived for maybe 800,000 years, we have been here as sapiens for 180, 200,000 years. She lived almost 5 times as long as we have. We have specimens over a long period of time, over a large geographical area, Tanzania, Kenya, Ethiopia. And this has become the reference collection for scholars. You heard Tim White's name mentioned when his team in the Middle Awash found what is known as Ardipithecus. The first thing they did was go back to the museum and open up those drawers of afarensis to make comparisons. So she grew in great importance, not only to the scientists, but also to the average person interested in this. We see jokes about her. This is like a cocktail party, and someone's being introduced, and he says, "Not the Lucy," as if that was the Lucy that had been found. So people make cartoons about her. In our country, you see her in crossword puzzles. If you see in the New York Times, fossil ancestor begins with L, 4 letters, it's Lucy. And she is very well known in Ethiopia. She has an Ethiopian name, which I think is very important. She's called Dinkinesh. You are beautiful, you are wonderful. But most people in Ethiopia know her as Lucy. And I always find it interesting when I go to someone's house for dinner and they say that their daughter's name is Lucy. And they say, oh, she was named after this famous fossil that was found. And driving in the countryside, you might find a Lucy College, you might find a Lucy coffee shop. The national women's soccer team in Ethiopia is named the Lucy team. So they use that name very often. She is one of Ethiopia's most precious antiquities. She doesn't live, she resides in the National Museum of Ethiopia in a laboratory, in very secure safes, and is looked after very carefully. But she means a great deal to the country of Ethiopia and to Ethiopians in general. They're very proud of contributing this to our knowledge. And in 1985, they minted this stamp. There's her name in Amharic, Dinkinesh, and this very fanciful reconstruction of the country of Ethiopia, Hadar up here, and the Lucy skeleton. And the local Afar people, as I said, have their name for her, and they call her Halomali. So you see she's reconstructed. Here is an entire skeleton by Owen Lovejoy at Kent State. And she is upright, bipedal, 2 feet, 2 legs. And there was a great deal of argument. Every time we would have meetings like this, there would be one side that said she walked upright, and the people sitting over there said, no, she didn't. And it was like a battle zone sometimes. And what happened was she stimulated Mary Leakey to go back to a site that she and her late husband, Louis Leakey, had worked in Tanzania, but had decided there couldn't be humans there because there were no stone tools. Because tools are so much part of our world. And it's a site known as Laetoli, about 3.6 million years old. And when we found these fossils at Hadar, she was stimulated to go back to Laetoli. And while they were there, they began to find teeth and jaws that looked exactly like the ones we were finding in Ethiopia. And also, most miraculously of all, they found a trail of human footprints. There were 2 of Lucy's species living in what is today Tanzania, who experienced a volcanic eruption with volcanic ash coming out, and it would cool and fall to the ground like it was snowing. But it was a volcanic ash, it was mixing with mud, earth, and it began to rain. And as they walked, of course they didn't have shoes, right? They left footprints, an imprint of their foot. And we had predicted on the basis of the bones that she was walking like we do, the striding, upright walking. And wouldn't it be incredible to see what the soft anatomy looked like? Well, fortunately, right after that, the sun came out. And it dried that volcanic ash so it became like cement, like this. And then there was another volcanic ash. And then when they peeled back that layer, there is the footprint left by one of Lucy's species, one individual, as he or her walked barefoot. Before that got hard, and you see the kind of footprint that we all leave when we go to the beach. If you go to the beach and you walk, you leave a footprint with your big toe, the large toe, with an arch from side to side, an arch from front to back, and a very deep heel strike. You cannot distinguish your footprint from this 3.6 million year old footprint. So in my view, her species had a locomotion, a way of getting around that was essentially not identical, but very, very, very similar to our own. I thought, wouldn't it have been nice if one of them had tripped and fallen on its face. And then we could see what they really looked like. One of the problems we had in the 1970s was that we had no good skull. I'm so envious of these skulls that reside. Where is your office here? Here. The preservation of the Dmanisi specimens that we will hear lots of discussion about the next few days is absolutely startling. I saw the fossils for the first time yesterday. I was so impressed with the details of anatomy. It's like you go to a museum where they have human skeletons and you pull a skull off the shelf. These are great treasures for your country. And the fact that they are here, the fact that they have been found by trained scholars, the fact that they have been dated to 1.8 million years by a volcanic layer is something that I think I can speak for everyone in this room who is here as a scholar. We never dreamed that we would find something like this between the Caspian Sea and the Black Sea. This shows that humans left Africa before they controlled fire, before they were very large-brained. All of our assumptions were wrong. They left right away. And they left beautiful skeletons to be discovered. We now have a beautiful female skull, so it would be like Lucy's. It's a little bit bigger. And we've also found a large male skull. And we know that males were much larger than females. They are not two different species. There's just a lot of difference in size between males and females. I didn't know what reconstruction to show. We don't know what ultimately they really looked like in detail. But certainly they had very ape-like faces with very small brains. This is as good, I guess, as many of them. But there is a gentleman in the audience who is a wonderful artist and anatomist and who has reconstructed many of these early humans. I should have shown a reconstruction that he did if I'd known he was going to be here. But we're getting a better idea of what Lucy and her type look like. Lucy is, of course, always in the news, as I said. And the latest is this very strange idea coming out of course, Texas, that Lucy died because she fell out of a tree. I mean, yes, we climb in trees. Lucy could have climbed in trees. But I think it's very doubtful. You can't see this illustration very well because it's overexposed, but it shows her falling out of the tree right on her feet. Now, I've fallen out of a tree as a kid, and I imagine many of you have. But none of you fall straight down on your feet and then fall over. You usually fall down on your back or your backside. And you usually have, if it's high, a lot of damage to the backbone. Lucy didn't have any damage to the backbone. But they looked at the cracks in the bones and said, these are the kinds of cracks that you would have if you fell like this. Okay. Well, I'm showing you a picture that was recently published in Science News that Tim White put together. And there is Lucy's arm bone. That's at the shoulder, where it articulates at the shoulder. And they said that these kinds of breakage, displacing fragments of bone, were due to her falling on her arms out of the tree. Okay, so looking carefully through the selection, through the fossils, there are so many non-human fossils in the National Museum in Addis Ababa. I mean, there are tons and tons and tons of these things. And here is the top end of an arm bone of a horse that lived at the same time that Lucy did. And you can see that, that there's a lot of similarity in the breakage. And that breakage is due to the very heavy weight of the sediments. Lucy was buried in sand that turned into sandstone. And then on top of that, for, I don't know, 60 meters, there was sand and clay and silt. And as it was beginning to fossilize, the pressure, the forces on it, broke the bone like that. This wasn't due to a fall, because I don't think very many horses fall out of trees, right? So that has been the latest strange publication to occur about Lucy. Well, I guess maybe it was this Lucy that they were talking about. This is, we in the United States, you won't know this, but we had for many, many years a famous television program called I Love Lucy. And it was about this woman, Lucille Ball. And on the internet, we found this picture of her in the tree. But anyway. One of the aspects that I've been trying to stress a little bit is, it happened to me on an airplane a few years ago when someone said, well, you know, I found Lucy. Did you ever find anything else? And I said, well, yes. And I realized that many of my presentations, I focused too much on Lucy, which I hope you don't mind. But we now have, this was the height of the collections in the late 1970s, but now there are fossils of her species found throughout the Afar region, the Middle Awash, north of us. Apparently, there are many specimens that have been found and not published. And we do have, as I said, a female and a male skull. So what kind of world do they live in? We have people like Kay Reed who study paleo environments and paleoecology. And it looks like for most of the time at Hadar, where Lucy was found and all of her other species members, was more forested than today. We know that Africa was much more forested. We know that in the Miocene, beyond 10 million years ago, there was a forest that continued all the way from the west coast, all the way across Africa, right to the Indian Ocean. We know that climate changes. We're in the middle of a climate change right now. And, but I think these were generally creatures that lived in more forested areas. They lived in groups or troops, probably not unlike what we see in chimpanzees, not identical, males and females and offspring. And they were certainly predominantly vegetarians. It doesn't mean that they didn't eat the occasional lizard or climb up and take birds' eggs, or collect crocodile eggs and turtle eggs from near the edge of the lake, but predominantly they were vegetarians. So I hate to draw family trees, but we're going to look at a couple, because everyone has their own idea of how all these things are fit together. But I'm making this very simple. In 1978, we named Lucy a new species, Australopithecus afarensis. I was invited at that time with a group, not unlike this, a group of anthropologists. Richard Leakey was there, David Pilbeam was there, Philip Tobias was there, I think Reitmeyer, who's here tonight, was at that meeting. And it was supported by the Nobel Foundation in Sweden. And it was called The Evolution of Man. You know, I tried to remind them that women evolved too, but the evolution of man. And I presented this hypothesis, a sketchy hypothesis. I suggested at that meeting, which was then later published in January the next year in Science, that Lucy's species, afarensis, should be considered an ancestor for other Australopithecus and also an ancestor for our own genus Homo. But the problem with that was, of course, there are no data Here, nothing, 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 nothing. 1.2 million years of nothing. Who is this young guy, Johanson, coming along and suggesting this idea? Well, fortunately, fossils began to be found, such as this 2.5 million year old skull in 1985, which is a kind of Australopithecus that is what we call a robust Australopithecus with enormous teeth, big crest on the top of its skull for chewing muscles, yet it had a projecting face like Afarensis. So it was a good intermediate form. It sort of gave us a picture of what happens along the evolutionary line here. But again, no early humans older than about 1.82 million years. Then in 1994, when we began our work as the Hadar Research Project back in Ethiopia, this upper jaw was found just here, and it's dated to 2.4 million years. Before, Homo only went back to about 1.8, 1.9 million. So this was a big step backwards. And this is what an ape upper jaw, the roof of your mouth, it is fairly long. It doesn't show it so much here because it's kind of distorted. But apes have very rectangular upper jaws. We have very rounded jaws. And this jaw at 2.4 million looks much more similar to this than it is to either Australopithecus or a chimpanzee. And furthermore, it was associated with stone tools. It is the only definitive association between stone tools and our own genus, unless there are things that are not published. And that gave us another data point on the evolutionary line. Now, I'm not going to say very much about stone tools, but since I mentioned it, and I know people will ask afterwards, there are people in the audience who know all about those things, much more than I do. But there have been some very interesting developments recently, because the oldest stone tools used to be 1.8 million. They were called Olduan tools because they were found at Olduvai. But now there is a suggestion, well, there's actually published and supported by accurate dating. There are large tools, and there are people here I hope will say something about this during this symposium. They're very large tools. They're not tiny little tools that fit in your hands. At 3.3 million, that would be a time when Lucy's species was living, right? So we don't know who made those tools because there are no fossils associated with it. And then a young, well, he's not so young, he's aging like all of us, Zaresanai or Zerai Alamseged, who was a postdoc at our institute and now is a professor at the University of Chicago after leaving California, found bones that are about 3.4 million that he and his colleagues believe show definitive evidence of cut marks made by stones. Once we began to make stone tools and began to harvest a new kind of food, not just vegetation, but meat or bone marrow, we were eating food of very high quality. You know, people who are animals that are vegetarians, what do? They eat all the time. You go look at cows in the field. What are they doing all day? They're just eating. They don't have time to do anything else. But if you have a carnivore, if you have a dog at home, you can teach that dog to roll over and sit up and bark, because it's smart, because it had to be smart to get its prey. It's easy to get a piece of grass. You don't have to sneak up to it. But if you're a carnivore and you're going after living creatures, you have to have a little more brain matter. This is very contentious. People don't totally accept it. And we at Hadar are in the middle of a project where we are collecting every bone from that 3.4 million year time horizon, and we're examining them for cut marks. Zerai is probably also known to you because of the fact that oh my gosh, he found a baby skull, complete skull, and part of the skeleton. What would have been a Lucy's baby. The most recent discoveries that we've made at the Institute, which were announced last year, I think, were made by Kay Reed, who is a paleoecologist and who is a member of our faculty. And we have a young Ethiopian scholar who's working on his doctorate with us by the name of Chalachu Seyum. And he went out. This was a spot which is called, you can't read it up there, it's the Lady Gararu site. That's the name of the area. And we went there in 1972. I know this place very well. And it was in our field notes. So Kay was reading those notes. And she said, I'm going to get permission and I'm going to go there, because the time range we thought for this was somewhere between around 2.5 million years, based on the pig skulls and things. And they found, unbelievably, Chalachu, our graduate student, very dedicated young guy, found half of a mandible, a lower jaw. This is the Lucy site here, and about 40 kilometers northeast is where this site is. And this is what that jaw looks like. And this is where that jaw was found, right there. And there was nothing else. But we know from the stone attached to it the exact horizon that it came from. And there is, fortunately, a layer that is dated at this site to about 2.8 million years. That took the origins or the presence of our own genus Homo another 400,000 years back in time. It's incredible. And from the very first moment I walked into the laboratory in Addis Ababa, that mandible was about 6, 7, 8 feet away. I knew immediately it was not Afarensis. And this has undergone an in-depth study with a number of people, Bill Kimball and others. And this is the inside of the jaw. This is the outside of the jaw. This is the top of the jaw, the bottom of the jaw. These teeth, doesn't show very well here, are fairly long and narrow, which is very much unlike Afarensis. The depth of the mandible from here to there, 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 here, is the same all the way back. In Afarensis, it gets very deep in the back. You see that you have 1 molar, 2 molars, 3 molars. That molar is hidden by this anatomy in Afarensis. And I won't bore you, but there are many, many features that place this into the genus Homo. But the rounded nature of the front of the jaw and the angled area there is what we see in Afarensis. It looks like this is a good, I use this very carefully, link between Afarensis and our own genus Homo. So we will be talking about Homo this week. Homo erectus, Homo whatever. Ergaster, I'm sure, will play a role. And here you're looking at a classic Lucy jaw, Afarensis. And the tooth rows are straight, whereas in our lower jaws, they diverge towards the back of the mouth. And they are arranged in a more rounded jaw rather than this rectangular jaw. So this is Australopithecus, 3.4 million. This is Homo at 2.8 million. We know Afarensis disappears at 3 million. maybe because of climate change. And we think that was a period of time when our own genus, Homo, began to arise. Now, yesterday, David was very, very kind, as I said, and showed me some of the original fossils, and I didn't have this slide in my presentation until he showed me this yesterday, because I thought, boy, this jaw, just here, whoops, reminds me of the Dmanisi jaw, or vice versa. This is clearly within our genus, Homo, at 1.8 million. This is in our genus at 2.8 million, and it's not as heavily buttressed here. It's not as heavily built out here, as you see in Dmanisi, but it's interesting. 1 million years separates these two, but there are already hints in this 2.8 million year jaw of what we see in these beautiful specimens from Dmanisi. So I think, getting towards my conclusion, that as opposed to when I made that hypothesis, which is still a hypothesis, it still needs to be tested over and over and over again, and it may be completely wrong. But since I proposed that, and since many other discoveries have been made, we now are able to do something that is very difficult. And this would be a long night's argument, and the person I would have that with, fortunately, is very tired, so we can't do that tonight. But that it really does look like we can begin to trace evolutionary lineages. We're going to find a lot more species out there probably. It's going to make it even more difficult. But it looks like at around 3 million years, Afarensis was the ancestor, perhaps, of both the lineage that led to us with a 2.8, 2.4 Homo, and this Australopithecus lineage over here, with its ancestor being this at about 4.2 million from northern Kenya called Anamensis. And there are other things like Gari that have the very projecting, you see the face is almost identical to Afarensis. It's got a very small brain size, it's got a little sagittal crest, it's got enormous teeth. It was probably another evolutionary experiment. There were probably many lineages out there. That's what something like that shows us. When I first took the introductory course at the University of Chicago in 1970, all we knew was Africanus, robustus, boisei, sapiens, heidelbergensis, erectus, Neanderthals. Now we have over 20 different species. And it's very difficult to connect the dots. But they're broken down into, I've broken them down into pre-Australopithecus, Ardipithecus, Sahelanthropus chadensis, the skull from Chad, and Tuganensis from the Tugan Hills. These I call pre-Australopithecus. There is a group of Australopithecus. This we don't know exactly what it is yet. There are these robust forms, Robustus, Gari, Boise, and Aethiopicus. And then there is our own genus. And there are many ways to connect all of these things. And any paleoanthropologist who tries to do this is going to draw it differently. They're going to draw it differently 5 years from now than they drew it 5 years ago. But generally, it looks like this 3 million year time range is very important because that's when we begin to see the diversification into a number of different lineages. Some species began to think their way out of those new ecological challenges by getting smarter. In other words, individuals who were smarter were chosen by natural selection to continue spreading their genes, as opposed to others like this group of robusts that began to eat their way out of the dilemma and become very dedicated, highly specialized vegetarians. And as I said, perhaps Afarensis or Lucy species was an ancestor to all of these lineages. I wanted to conclude by saying that Ethiopia's contribution to paleoanthropology, our knowledge of the human past, is extraordinary. You have fossils as old as 6 million years. There are several different species here. You have what used to be the earliest stone tools from Gona that we found on our expeditions in the 1970s and are now being excavated by Seleshi Samau, who is in the audience tonight. And the appearance of these robust forms, the earliest Homo at 2.8, Homo erectus, maybe something called Rhodesiensis, and of course the appearance of our own species, Homo sapiens. So it has been a distinct pleasure to work in Ethiopia, to have played some role in trying to understand the diversity of human ancestors and some of the details of this fascinating story of how we came to be who we are today. And I guess the single message to take home is that it all began in Africa. We are all Africans, regardless of color of skin or shape of hair or whatever. Our genes, the oldest ancestral genes that we have in our body, came from Africa. We came out of Africa, we know now from the Dmanisi fossils, at least 1.8 million years ago. Over 3 times further back in time than we thought as a graduate student when I was at the University of Chicago. So these fossils bring a terribly important message to us, I think, about the commonality of our origin. We should look back on that commonality and understand that we really are a species that is in the same species. We are individuals in the same species. What happens to Homo sapiens happens to all of us. And it is really a time for us to recognize that it was through the process of natural selection, living under natural conditions, that we became who we are. The real creator, in my mind, for humans, is not a supernatural creator, but is the very natural world itself. And we are at a critical time in the history of this planet, in the history of this species, where we really need to pay attention to the natural world and stop acting as if there's someplace else to move to. We are on Earth and there's no other place to go. So I want to thank you so much for listening and giving me the opportunity to be here this evening and to tell you a little bit about our ancestry and how we came to be. Thank you so much.
მე მგონი ყველამ ერთად ძალიან დიდი მადლობა უნდა უწყნათ დონს ამ შესანიშნავის აღამოსთვის. მე მინდა მიუმატო კიდევ მადლობა, განსაკუთრებული მადლობა მინდა უთხრა საზოგადოებრივ მაუწყებელს, რომელთან ერთადაც ჩვენ ვიწყებთ ძალიან მჭიდრო თანამშრომლობას და დღევანდელი საღამო იყო სტრიმითაც, ამის გარდა იქნება მისი ვიდეო ჩანაწერთ, ისევე ამ კონფერენციის და საერთო სტუდიოც ძალიან ბევრ საინტერესო რამეს გვპირდება და ჩემთვის ძალიან დიდი პატივია, რომ დღევანდელი საღამო ესე გაიხსნა. I think we should all thank Don for this fascinating journey past, and we are ready to start tomorrow discussion. Tomorrow we will have opening of our first Zenckenberg conference in Georgia. Not last, right, Friedman? And I'm very proud to say that tomorrow we can start this conference and later we could spread what we talked to the public. It means that our field and National Museum is open for public, and I want to say many thanks for organizing this conference, and we will have more opportunities to talk about it, and really with my friends and colleagues from Germany, Frankfurt, Zenckenberg Museum, we all try to have from tomorrow big party of science. And also I want to thank Professor Henri Delumley. it's my personal approach to tell him thanks, because he was somebody who intoxicated me and our team with museum, and then our museum became open. Is his fault too. So thank you very much, everybody, for coming here, and thank you, my colleagues, that we can share this beautiful day with you. Thank you very much.